Okay, 12.3 is multiplying rational expressions. We're still going to do a lot of the same stuff that we did when we simplified, but we're just going to add a multiplication to it. So when you are multiplying monomials, remember a monomial is a single term with no pluses or minuses. Things like 7 is a monomial. Things like 2a. Things like 3x squared y. Something like 3x squared plus y is not a monomial. The plus sign means there are two terms. We want just one term, so this is all multiplication. The first thing we want to do is factor out a GCF, just like when we're simplifying. We're also going to cancel like factors, like you did before. So remember, 3x plus 2 over 3x, we cannot cancel the 3x's here because the 3x on top is a term, it's part of a binomial. However, if I have 3x times x plus 1 over 3x, now 3x, since it's being multiplied by something, has become a factor. We can cross those out. So again, cancel like factors. And we can also use exponential rules to simplify. Remember our exponential rules? If we have a cubed over a squared, that's the same as a to the first. If we have a to the fifth over a to the seventh, that's the same as 1 over a squared. In other words, there's 5 a's on top, 7 on the bottom. If I cross out the common factors, the 5 a's, I'm left with 2 on the bottom. So we can use our exponential rules to simplify. So let's take a look. Multiplying monomials. I'm going to do one first with just numeric values. 2/3 times 21/10. Now you all know that you could multiply straight across. You can multiply 2 times 21, 3 times 10, and then simplify. But it's much easier to simplify first. And when we start to add variables and things, you'll see how the factoring will come in handy. 2 and 3 are prime. We can't factor them. 21 is 3 times 7. 10 is 2 times 5. And now I can cancel my like factors, and I get 7/5. So even though there's a multiplication there, remember, when I multiply, the top becomes 2 times 3 times 7, the bottom 3 times 2 times 5. Cancel your like factors, and you're all set. Doesn't matter whether we've multiplied first and then cancel, or cancel first and then multiply, as long as you're canceling something on the top with something that's exactly the same in the denominator. So now we're going to add some variables to this and take a look and do the same thing. So 5ab cubed over 8c squared times 16c cubed over 15a squared b. So again, a couple ways to look at this. I'm going to start to look for simple numbers that will cancel. I'm going to multiply the top, but leave it in factored form. Times ab cubed c cubed. Notice when we multiply, the top times the top. When we multiply, order doesn't matter, so I can bring the numbers to the front and the variables gathered together at the back. At the bottom will be 8 times 15 times a squared b c squared. So looking at my numbers, 5 goes into 15 3 times, 8 goes into 16 twice. At my variables, a over a squared. I'm going to write my 2/3 first before I lose track of them. A over a squared is an a on the bottom. B cubed over b, 2 extra b's on the top. And c cubed over 2, again, 3 minus 2 is 1. So I've used my exponent rules for the variables and used factoring for the numerics. Try this one for me. 12xy squared over 45mp squared times 27m cubed p over 40x cubed y. Pause the video and give that one a try. Okay, I'm going to work this a little different way. I'm going to just do my canceling first. I know that 45 and 27 are both divisible by 9. And I know that 12 and 40 are both divisible by 4. I have 3 times 3 on the top, 5 times 10 on the bottom. I don't think I can cancel my numbers any further. So up top I have 3 times 3 is 9, 5 times 10 is 50. Then I'm going to do my x, y squared and my m cubed p, my m p squared, my x cubed y. All I've done is copy the variables on the top to the top, bottom to bottom. Let's look at our x's. I've got an x on the top and an x cubed on the bottom. So again, x over x cubed, 2 ways to look at this. I can say that this is x times x squared, so my x's cancel. Or noticing that I have 1 on top, 3 on the bottom, which means when I cancel, I have 2 extra on the bottom. My y's, y squared on the top, y to the first on the bottom, that's a y on the top. M's, m cubed over m, 3 minus 1 is 2. And my p's, p over p squared, p on the bottom. So that's my final simplification. All right, let's move on to polynomials, meaning that I'm going to have binomials and trinomials. So again, if you need a separate sheet to work on your factoring, make sure you are keeping up with that. The important thing with this is that we have to factor first. If you don't factor first, you're going to be in big trouble. When I'm multiplying numbers, let's do this. I could multiply this first and then divide both top and bottom by 3. I think that most of the time it's easier to cancel first. 6/3 is 2 over 1. 2 times 2 is 4 over 3. But when the numbers are small and I don't have a lot of variables, I can multiply first and then factor. However, when we get into polynomials, it is crucial that you factor first and then cancel before you multiply. Factor first, cancel second. So let's look at one of these and you'll see what I'm talking about. X minus 5 over x times x squared over x squared minus 2x minus 15. I'm going to factor first. X minus 5 does not factor. X is simplified. I could factor x squared into x times x, but since it's a monomial, I'm going to keep it. This is the piece that needs to be factored. X minus 5 times x plus 3. Factors of negative 15 that add up to negative 2. I'm now going to cancel. My x over x squared becomes simply an x on the top. So I have x over x plus 3 as my final simplification. Okay, let's try another one. A squared plus 7a plus 10 over a plus 1 times 3a plus 3 over a plus 2. Pause the video and look at all 4 of our pieces and see if you can factor any of them. Okay, the numerator here on the left becomes x plus 5, a plus 5, a plus 2 over a plus 1. I'm going to go ahead and put that in parentheses. I should have said that up here. When I have a binomial, 2 terms that don't factor, I always like to put it in parentheses so that I don't forget that that's one big factor and that I can't cancel the a's separately. This binomial does factor. 3 is the GCF, leaving a plus 1, and then I have another binomial that doesn't factor, but I'm going to put it in parentheses to remind myself. All right, a plus 1 and a plus 1. A plus 2 and a plus 2, leaving me with 3 times a plus 5. Now in this case, it's okay to leave your answer in factored form. You could go ahead and distribute this, but you don't need to. This is a perfectly fine answer. What we're looking for is that all of the common factors have been canceled. So factor and cancel, and then all we have to do is write the pieces that are left over. We can also use this tool to change units. So if somebody did the 100-meter dash in 9.87 seconds, and I want to know how fast was that in kilometers per hour. So 100 meters per 9.87 seconds. Let's take care of the meters first. If I want to cancel meters with kilometers, I know that there's 1 kilometer for every 1,000 meters. Seconds. I know that there are 60 seconds in 1 minute, and I know that there are 60 minutes in 1 hour. So look at the units. Seconds cancels with seconds, minutes with minutes, meters with meters, and I'm left with kilometers per hour. So 100 times 60 kilometers per 9.87 times 1,000 hours, kilometers per hour. So putting all those numbers into your calculator, don't forget to multiply everything on top, then divide with a parentheses around the bottom as well, and I get 36.47 kilometers per hour. So that's using this idea to cancel and change units. All right, we'll do a couple more practice problems before I let you start in class. Remember, factoring is incredibly important here, so keep up with that.